Hi there, my name is Mark, and this is Pacific Northwest Solar. Our family has a solar array installed at our property in rural western Washington state, on the west coast of the United States. I've been inspired by other YouTubers to share my experience with our solar array and how it impacts my power costs. This video details my results for June of 2024, and I hope it will be useful information if you are considering getting solar at your home. Please also see the link to my separate video that gives more details on our installation, listed below in the description. I have added some additional content which I hope you will think is useful. Here's a picture of our 16 kilowatt ground mount solar array. The solar array is directly south facing in one of our pastures, with no trees or other obstructions around it. We have 50Z and Shine panels, rated for 320 watts each, with Hoymiles M300 microinverters on the backs of the panels. These microinverters convert the panel's DC output to 240 volt AC power, which is sent back to the breaker panel at the house. There is only one choice of electricity providers where we live. Currently, the cost of electricity from the grid is the same no matter what day or time it's consumed. No time of use rates. Any power generated automatically goes to usage in the house first, and then any additional is automatically returned to the grid. We get a 1-to-1 credit for each kilowatt hour that we send back to the grid. These credits directly deduct from the power we are charged at the end of the month. As you can imagine, the overall idea is to overproduce in the summer and use the credits to reduce or eliminate the electricity bill in late fall and winter months. I am using a Sense device in my electric panel to track power generated and power consumed. And I have written a custom Python program to capture real-time metrics for the entire system that I save and analyze. This is what the Sense app looks like, showing the statistics for the month, including solar production, usage, energy to the grid, and energy from the grid. Solar production is very high, over 2,330 kilowatt hours for the month. The fully blended cost for electricity in this month, including all taxes, fees, credits, would be 12.7 cents per kilowatt hour, which is about 10 pence per kilowatt hour for my UK viewers. Using this rate, the value of the solar production for this month was $297.12. The cost of my usage would have been $151.57 at this blended rate if I didn't have solar. Here's a look at the solar production for June 2024 by day. Total production for the month was kilowatt hours, with the lowest day being 25.2 kilowatt hours on June 2nd, and the highest being 111.2 kilowatt hours on June 5th. The total monthly production was slightly larger than May. The overall average production per day was 77.7 kilowatt hours, which is quite impressive. The total amount of hours of sunlight per day went from 15.6 hours at the start of the month to 15.9 hours at the end of the month. There were some cloudy days in the month, but there were 9 days where production was above 100 kilowatt hours in a day. I expected more solar production this month, but the weather was not as warm as usual for June. You can certainly see how much it varies by day. Here's some additional details for the highest solar production day, June 5, 2024. At my location, the sunrise was at 5:13 a.m. and sunset was at 9:00 p.m. for a total of 15.77 hours of daylight on this day. The highest 1-minute sampled solar production was 13.3 kilowatts at 1:24 p.m. Very impressive production. Sunny almost all day, with 3 brief cloudy times. Here is solar production and actual usage, plotted together for the highest solar generation day of the month. The morning high spike on the usage graph is from the electric furnace turning on. The other spikes during the day were either dishwasher, laundry, or cooking dinner. Here is solar production, overall usage, energy sent to the grid, and energy from the grid on a per-day basis for the month, relative to each other. Usage, in this case, is power used by the house, regardless of whether it came from the solar panels or not. The large to-grid spikes were on days with high solar production. Electricity sent to the grid is dominating the chart, which is exactly what I want to see at this time of year. Here's a comparison of the June 2022, 2023, and 2024 solar production, along with the yearly totals for each year. I really enjoy looking for patterns in the 3 years of data I have now. I think the adjustments made to the direction and angle of my solar array last June are really showing an increased production. June has the peak of the solar year, and production was higher than any month this year so far. As a way of comparison, the PVGIS website suggests that I should get 2,060 kilowatt hours at my location during this month, so my actual exceeded this by 10%. Here is the month-by-month comparison of our usage between 2022, 2023, and 2024, along with the yearly total usage. Cumulative usage for 2024 is significantly lower than 2023 and 2022, by more than 4.5 megawatt hours. I'm very happy with this overall yearly usage reduction. Here is the month-by-month comparison of the actual amount that I paid the power utility each month for 2022 through 2024. My bill was $7.49 this month, for 3 months in a row, which is the standing charge. My solar generation offsets all my power usage on a per-month basis, and I'm building up credits to be used in the winter. My credit total is over 1,700 kilowatt hours so far. Here is a graph that shows the lowest and highest recorded temperatures in Fahrenheit for June 2024. The high temperature of 84 degrees Fahrenheit, 29 degrees Celsius, was pretty typical for June, but there were quite a few days where the overnight lows were in the 40s, which was not typical. Thanks for watching. Please give this video a thumbs up so other people will be able to view this video. If you have any other statistics that you would like to see, please leave a comment down below. Have a great solar day and see you next month.